Okay, here we go, guys. 5.2, here we go again. Perpendicular and angle bisectors. Again, bisector cut into two equal parts. In fact, they cut into two equidistant parts, which means they're an equal distance from that center. Okay, your midpoint's equidistant from the two endpoints. Keep that back to your head. Equidistant. Equidistant. Here we go. Let me zoom in a little bit. Not my school computer. Where is it? Where is it? Where is it? Okay. 5.2 perpendicular bisector theorem. What it states is if PM is perpendicular to AB and MA is perpendicular to MB, so we have a perpendicular bisector, then PA is congruent to PB, equal distance. Okay? Think that'll come up on proof? It might. In fact, you'll prove this in exercise 32. Okay, so if I draw a perpendicular bisector, means that these two things that connect will be congruent. Okay. Converse of that says if you have a triangle in PA, it's congruent to BB. If you draw a perpendicular line through here, if you draw a line perpendicular to the base, then guess what? Those two halves will be congruent. Okay? What's this do? Oops. Oops, you. Okay. Man, I really gotta move that zoom back where it should be. Okay. Here we go, let's use that theorem. What's the length of QR? Now, if these two halves are congruent, that's perpendicular. By a perpendicular bisector theorem, it tells us that PQ is going to be equal to RQ, right? And PQ equals 3n minus 1. RQ equals 5n minus 7. So I'm going to add 7. 3n plus 6 equals 5n. So I'm going to subtract 3n. Get 6 equals 2n. Divide by 2. Divide by 2. 3 equals n. Am I done? No. Then you have to plug it in, plug it in. So 3 is my n. I go up to QR. 5 times 3 minus 7. 15 minus 7 is 8. And that is my answer. Capiche? Capiche. Alright, here we go, word problem. You're a director of a park at the right and it wants a t-shirt stand built point equidistance from spaceship, chute, and rolling coaster. And the rolling coaster. By the perpendicular bisector theorem, he can place the stand anywhere along line L. Suppose the park director wants t-shirt stand be equidistant from the paddle boats and the spaceship chute. What are the possible locations? Okay. Okay. So I need to find it so it's equidistant from the paddle boats and the spaceship chute, right? So the first step I'm going to do is I'm going to draw a line from the paddle boats to the spaceship chute. Okay? So first, draw a line. Second, we're going to find the midpoint. Okay, so between S and P, I'm kind of guessing here, guys. Don't play it cool, play it cool. Actually, no, I'll even grab my ruler. Watch this fancy stuff. So that's about 7.5. Half of 7.5 is 3 3/4. So about right here. That's our midpoint. Okay. Now we take our midpoint and we construct a perpendicular. And we're going to construct a perpendicular line through M. And where they cross, this point right here, called point P, will be equidistant from P, S, and R. Okay? So boom, we found it. We find midpoint, then we use perpendicular bisector, and we see where they cross, and that was point P. That's a tough one. If ever you see the term equidistance and you have to find the point equidistance from multiple spots, you're finding perpendicular bisectors, guys. Okay. Here's a good definition to keep in mind. Whenever you hear me talk about distance or the distance of a line, distance is the length of the perpendicular segment from the point to the line. So for example, from this point, P, the distance to it would be the perpendicular. So this would be distance. Okay? Not if it's not perpendicular, guys. Well, especially not if it's curved. But distance is the perpendicular distance. If you find the distance from P to a line, you're drawing a perpendicular line to the other line. Okay, angle bisector theorem. Let's blow this up. Okay. What the angle bisector theorem says is if you have an angle bisector QS on some angle Q, then you put a point on that bisector, we'll call it S, then the distance from S to each of these lines, well, is congruent. These will both be congruent, okay? You might say, Mr. Willigan, when does that ever come up? Well, more often than what you think. We're gonna see, we're gonna see. Now the opposite is also true and probably more used. Let's say you have these two rays, you have a point, you draw the distance to each of these, a perpendicular line. Well, if you connect Q and S, you know it's going to be an angle bisector because these two lengths are congruent. Okay? Okay, last example. We have an angle bisector here. We have our two distances. If this is an angle bisector, I know that BF is congruent to DF. And BF is congruent to 6x plus 3. DF is equal to 4x plus 9. So now I do some handy dandy algebra. Subtract 3, subtract 4x. 2 steps in one. It's crazy. So you get 2x equals 6. X equals 3. Are we done? No. I take that 3, I plug it back in for FB. 6 times 3 plus 3. 6 times 3 is 18. 18 plus 3 is 21. And that is our answer, boys and gals. Hey, I'm going to do another example like that crazy park one in class and show you another one. Okay? Enjoy!